going on? I am here with your first video of the semester. Today we will be covering 4.2 angles and their measures. Alright, so let's get started. Alright guys, an angle consists of two rays, alright, starting from a common endpoint. One side is called the initial side and the other side is called the terminating side. Alright, again, just a quick review. A ray, guys. Alright, a ray. Alright, is a line in one direction. Alright. One direction from a point, has a starting point, it goes in one direction. The initial side is where it starts. Alright guys, on the unit circle in a coordinate plane, the initial side is going to be right here, 0 degrees. Alright, 0 degrees. And then the terminating side is whatever the angle measure is. So hypothetically, if this was 0 and this was 30 degrees, alright, the initial side would be 0 degrees, the terminating side would be 30 degrees. Alright, so just want to throw that out there. Alright, so you have what's called a vertex. Your vertex is this center point, alright, where each ray started. Alright, and now you have an angle that went this way. Alright, so this is more than 180 degrees. Alright, so this is like a negative angle because it went this way. Alright, this is a positive angle. This is more than 360. Because see, I went one full rotation and then again, so that would be like 390, hypothetically, you know. Hold on real quick. Go open the door. Alright, so let's continue. Direction and distance are important when discussing value of an angle. So again, guys, if it travels up like this, the terminating side is going to be a positive. All right, it's going to be a positive degree or positive radian, which we'll talk about radians and degrees in a second. If it goes down, all right, and then it could go here, it could go all the way around. All right, it doesn't matter, but that's a negative angle. All right, that's a negative angle or a negative degree. Okay. All right, in trigonometry, it is important to establish a norm for positioning of an angle. The initial side is centered at the origin and extends to the positive side of the x-axis. This is standard position. All right, so standard position started right here at the origin. All right, and then it went here in a positive direction. So we have a positive angle. This one right here is going to be a negative side, a negative angle. All right, this was positive. This one's negative. All right. So it says, what would be 45? What would 45 degrees look like? All right. So you got to think about it. We're going to go deep into it tomorrow when we have a lab. But 45 degrees, right? Remember, 90-degree angle is a right angle. 45 degrees is half of that. All right. Negative 90. Well, negative 90, remember, for a negative angle, from here you would go this way, right? There's your negative 90 degrees right there, right? That's a positive 90 right there because it went this way. It goes down. That's a negative angle. All right, what is the degree measure of one full rotation? Well, if you think about a full rotation, that's a circle, right? 360 degrees, okay? Can you have values larger than one rotation? Absolutely. All right, absolutely. All right, if I go around once, that's 360, but if I keep going, right, let's say I went there. That'll be 360, the one rotation, plus 90, right? That's gonna be 450 degrees, all right? So again, I just added 360 plus the 90, right? That gave me 450. All right. So you can have values larger than one rotation. Okay. All right, right here, man. A radian. A radian is when a radius of a circle equals the arc length of an angle. That is one radian. All right. Radians are the number of measures we will most often use in trig or pre-calculus. This is the trig portion of our pre-calculus. right? It says pi. All right, pi is 180 degrees. So when you have that coordinate plane, all right, 0, pi. All right, that's pi, an angle that's 180 degrees. Because 180 degrees, if you remember, that's a straight line. All right, that's a straight line. 180 degrees is a straight line. So from here to here, that's a straight line. All right, and then if you kept going, that's 1 pi. Another straight line is another pi. So pi plus pi is 2 pi. All right, which is the same thing as 360 degrees. I'm gonna show you how to convert these in a second. All right, but 1/2 a rotation is pi. A whole rotation is 2 pi. And that's for radians. All right, radians. Okay. Now convert. All right, it says to convert a degree measured to radian, we use the conversion factor pi over 180 or 180 over pi. Pi over 180 is for degree to radian. 180 to pi is radian to degree. All right. If I want to convert a degree to a radian, I use this one. If I want to convert a radian to a degree, I use this one. And all it is, guys, is in a nutshell. Just look at this, right? So this one has pi in it. That means this is a radian. So I'm going to go from a radian to a degree. So how I do that is it already has pi. So I want to divide out the pi, so I use this one. So I go 180 divided by pi, I multiply. All right. So what happens is the pi will always cancel, and I'm left with 180 over 6. All right, which reduces to 30 degrees. All right, so you convert it. Pi over 6 is the same thing as 30 degrees. This one is a degree, 120 degrees. All right, so to convert that, I need to add pi to it. So I'm going to multiply by pi over 180. All right, so I end up with 120 pi over 180, which we can reduce that, guys. All right, anyway, 120 and 180, I just look at 12 and 18, they're both divisible by 6, so that's 2 pi over 3, all right? 120 divided by 180, it's 2 over 3, so 2 over 3 pi. Now it's a radian, all right? So here you go, you got 3 pi over 4, convert that. All right, remember we're gonna multiply by 180 over pi because we want to eliminate the pi. Pi's cancel out. So I have 3 times 180 over 4. And then just reduce that. That's going to be 135 degrees. All right, 135 degrees. All right, just practice. That's all you gotta do is practice. All right, this next one right here. Convert this one to 2.4 radians. All right, you do the same thing. I want to convert that times 180 over pi. All right, and if you multiply that, 214 divided by, times 180. Let's see, 214 times 2.14, oops, times 180. It's 385.2. divided by pi. And when you do that, you get approximately 122.61 degrees. All right. And then lastly, 330. If I want to convert that to radians, I multiply by pi over 180. So 330 pi divided by, oops. All right, and then just reduce that. We're going to get 11 over 6. Pi over 6. There we go. 11 pi over 6. Yep. That's a radian. All right. All right. Let's see here. Reference angles. Reference angles are the measures of an angle from the horizontal axis to the terminating side of an angle in standard position. All right, again, a reference angle is the measure of an angle from the horizontal axis. All right, if you remember, Horizontal, guys, is a straight line like that. All right, that's horizontal. So it's the distance or the angle from the horizontal axis, all right, to the terminating side. All right, so let's look at this. Here's the horizontal axis right here. I want to highlight it for you. Here's the horizontal axis, right? Here's the terminating side. All right, this angle right here would be the reference angle. This is the reference angle. All right, right here. Here's the horizontal axis. Here's the terminating side. Right? So the reference angle is going to be this angle right here, from here to here. All right? So this isn't that hard at all. You just got to look at it. Here is the horizontal axis again. Right? Here is the terminating angle. Right? So there's my reference angle. So it's the angle measure right here. See that? Angle measure between the horizontal axis and the terminating side. Oops, that's a terrible line right there. There we go. Right? So right here is an example. This says, what is the reference angle to 267 degrees? Well, we're going to get practice on making a unit circle. But we know that this is 0. This is 90 degrees, right? 90 degrees, that's the little box. 180, 270. So 267 would be between 180 and 270. 267 would be over there. Right? So now I just need to find this reference angle right here. So what we're going to do is 267 minus 180. All right. And when we do that, we're going to get 87 degrees. All right. For this next example, I don't know why I erased all that. I still need 90, 180, oops, and 270. All right. Now 126 is right here. All right, it's in that quadrant. So the reference angle would be right here. Okay. So I need to find a distance or the angle measure between 180 and 126. So I just take the larger number, 180 minus 126. All right, when I do that, I get 54 degrees. All right. So that's the reference angle for 126. We just did the reference angle for 127. Sorry about that. All right. Now let's look at our next example. All right, coterminal angles. Coterminal angles, as we stated before, coterminal angles end at the same side. All right, same side, starting in standard position. Let's find some values of coterminal angles. What I like to do is this. All right, well here, let's just find one positive and one negative coterminal angle for each. All right, so coterminal angles are really simple. All right, because they have the same terminating side, they're all the same. Like, it's just adding more circles. All right, or a 360-degree rotation. Let me show you. Hold up, that's a terrible line. All right, so if I made one line, right? Let's say I made this line right here. Oh, wrong. There we go. I don't know why that keeps happening. All right, let's say I made hypothetically an angle right here to 60 degrees, right? Well, if I go in a complete circle from here, 360 degrees, all right, that's a whole circle. Well, I just add 360 to that. all right, which would be 420, all right. But if I go the other way, if I subtract it from 360 and went back this way, that's a full circle as well. But that would be 60 minus 360, which would be negative 300. All right. So all I do from a terminating side or angle measure is add 360 and subtract 360 until I get a positive angle and a negative angle. And you can do that multiple times. All right. Like, for example, if I wanted to find another negative angle here, I would just do negative 54 minus 360. All right. And doing that, I'll get negative 414. Negative 414. All right. You can actually do that again. All right. That's coterminal. You could also go negative 414 minus 360. All right. And that'll give you negative 74. Both of these are coterminal to this. But those are negatives. See? That's a negative coterminal angle. Well, I want a positive coterminal angle. So to find a positive, I could do negative 54 plus 360, right? And that'll give me 306. All right. If I wanted to add, or let's say I want to find another coterminal angle, hypothetical, I could do 306 plus 360 again and get 666. All right. These are negative coterminal angles. These are positive coterminal angles. And it's simple. Those are negative. So they're negative coterminal angles. These are positive. So they're positive coterminal angles. Make sense? All right. So let's try another example. Right here. To find a negative, I could do minus 360. Oh, man, didn't mean to do that. Minus 360. And that'll give us a negative 202. And if I want to find a positive coterminal angle, now I know you're like, this is already positive. Yeah, but find a coterminal angle too. All right, so I'm going to add 360. All right, and I'll get 518. All right, negative coterminal, positive coterminal. All right, and then one more. Negative 658. All right, minus 360. Actually, you know what we could do for this one? I'm going to add 360 because that's so large. That's such a large negative number, or small negative number, right? That if I add 360 to it, it'll still be negative. All right, so negative 298. All right, it's still negative. That's a negative coterminal angle. But if I took negative 298 and added 360 to that, I'd end up with 62 degrees. All right, so both of those are coterminal to negative 658. Those are coterminal to that. Okay, one positive, one negative. Okay. Now, we got some practice here, and it is these problems right here. Okay, they are on E-class. All right, if you need to look here at the video for them, I can always just leave the problems right here for you. Write those problems down, and there are your problems. All right, there are your problems right there. Just get them in one screen. All right, there's your assignment. So work on these, and please read the directions. All right, make sure you sketch this, and let's talk about it in class. And I will catch you later.